Thank you for joining me today. I'm excited to present the findings of our final report for the Building Energy Modeling class. In this presentation, I'm going to talk about the selected location for a four-story office building with a basement. I'm going to mention two out of four energy efficiency measurements used on our model and their results, and the use of fixed shades with those EEMs and without them. The goal of this final report is to find energy consumption patterns and identify efficiency parameters with the model for the owner of the project to determine a more efficient outcome for the one mentioned. Starting at the location selection, we were given seven different places across the United States to simulate building peak loads on the baseline model. Out of those locations, we had Greenfield, Indiana, Greensboro, North Carolina, Gainesville, Florida, Fort Myers, Florida, Chicago, Illinois, Atlanta, Georgia, and Cruz Bay, Virgin Islands. Out of all the simulation, we found that Cruz Bay has an extremely low peak heating load and a moderate peak cooling load as compared to others. This is a favorable combination without any kind of energy efficiency measurements or phase shades yet. In the next following slides, I'm going to show you the energy efficiency measurements that we picked and also their results. The ones that we're talking on this presentations are the EEMs on exterior walls and on thermostat management. For the exterior wall, we decided to change the construction material. We also decided to change the exterior insulation. We decided to add some additional insulation as well. And we decided to also add some interior insulation. For the thermostat management, we decided to do some cooling and heating set point change for both occupied and unoccupied periods. For the exterior wall results, we found that there was a slight decrease of 0.12% in annual electrical consumption as compared with the baseline model. Unfortunately, there were no change in annual gas consumption, but we still find that this was a relatively efficient measure for this model and location. However, for the thermostat management results, we found an increase of 3.83 in annual electrical consumption and an increase of 0.12 in annual gas consumption. This is concluding that this is an inefficient measure for this model in location. It could be efficient in other locations, but not in this one. The other parameter that we used were fixed shades. We decided to put three fixed shades surrounding the building in the northeast side, southwest side, and southeast side. These were 100 feet by 150 feet fixed shades that after running the simulations with the EMs, we found that combining those two actually increases the annual electrical consumption by 3.51 with the exterior wall insulation and 7.32 with the thermostat management. That is really high. Nonetheless, we did found that removing the EMs and only running the fixed shades with the baseline model, there's a decrease of 3.76% in annual electric consumption only using the fixed shades around the model. This is concluding and very conclusive that it's definitely more efficient to use fixed shades without the mentioned EEMs. For the conclusion of my presentation, I want to mention that two out of four EEMs implemented in the complete report were very efficient. Exterior walls were slightly efficient without the fixed shades, but the thermostat management set points failed in this location. It might be useful in other location, but not in this one. The fixed shades surrounding the building alters the EEM results, so the EEMs have to be modified accordingly for more practical parameters if fixed shades are present, so you can make your building even more efficient. Thank you very much for your attention.